Hello Finxters and welcome to a new Pandas tutorial. In this tutorial we will learn how to use the Pandas function pivot table, and this function is used to create a pivot table as a data frame, and it allows for lots of customization possibilities to provide some informative insights into our data. And we will start with an introductory example. First of all, we import the Pandas library and the NumPy library, which we will need later on. Then we create the Pandas data frame and assign it to a variable called df. And the data frame looks like this. It contains information about players of two baseball teams. And for each player, we get the player's team, position, throw arm, throw speed, and running speed. And now we apply the pivot table function. And it just looks like this. I will explain what I'm doing here in a minute. So inside the function we pass in the data frame as the first argument. The second argument is the values parameter. And the values parameter expects the column or the columns that we want to aggregate. And we assign it the column throwing speeds. And the next parameter is the index parameter, which we assign to be the index of the new data frame that we want to create. And the last parameter is the aggfunc parameter, that stands for aggregate function. And this parameter expects the function that we want to apply to the aggregated column, and we set it equal to np.mean, and this is the mean function of the NumPy library. This wouldn't actually be necessary to apply it to the aggfunc parameter, because the default value for this parameter is np.mean. So if we didn't apply that here, that wouldn't make a difference. We do it anyway to make it easier to understand what's happening here. And yeah, the output is a new data frame with the team column as the index. And for each team, we get now the average throwing speed. Because the throwing speed column is the aggregated column, and we assigned the aggfunction parameter the np.mean function. So we get the average throwing speed for each team. We can also apply multiple indexes, which I will do now. So instead of just team, I will apply a list here with team and the other column position. And so we go more into detail here, and this way we get the average throwing speed for each position of each team. And yeah, the outputted data frame, the output is again a data frame, and as I said, we now have the average throwing speeds per position per team, so it's a little more into detail here. And yeah, this way, by applying multiple values to the index parameter, we create a multi-index data frame. We can also use the column throw arm, which we haven't used yet. We could also, like we did here, assign it to the index parameter as an additional index. So I just add throw arm. And the output now, the outputted data frame now shows the average throwing speed per throw arm, per position, per team, which is actually a bit confusing. It's a little bit, there are too many indexes here, and it's just a little bit, it's just too confusing to read it this way. But we have another option with this function. because we can use the columns parameter. And let me just do that. So instead of assigning the throw arm column to the index parameter, I will apply the columns parameter and assign it the throw arm column. And yeah, this way we get actually the same information as we had in the data frame before, but this approach is just a bit clearer, and it's a bit easier to read and to understand like what's happening there. So by combining the columns parameter with the index parameter and not just using the index parameter, we can get lots of information out of our data, but in a just more comprehensible way, and it's just easier to understand. So by now we have only seen the NumPy mean function. Of course, we can apply other functions here. For example, we could change np.mean to np.max. And this now shows the maximum value of the throwing speed of each throwing arm and position and team, which is again a lot of information, but it's like a lot of information, but in a very comprehensible data frame, in a relatively small data frame, because as we can see compared to the data frame we had above, these are just half as many rows, and it's just yeah, a lot of information. And by assigning different NumPy functions, or even other functions, doesn't have to be NumPy functions, we can calculate lots of different things out of our data. We can even apply multiple functions. So by now we've only applied one function for the whole data frame basically, but we can also apply multiple functions or even different functions for different columns. But in order to do so, we first have to assign the values parameter multiple columns to execute different functions on different columns. And this is what I will do now. So first of all, we add here to the values parameter another column, which is running speed, which is a column that we also haven't used yet. And now going to the aggfunc parameter, we can assign a dictionary. I will explain that in a minute. Actually, we can put that in a new line so it's a bit more easy to read. So throwing speed, we assign that np.mean, and running speed np.median. And yeah, so first of all, we assigned the values parameter additionally to the throwing speed column, the running speed column. And the aggfunc parameter now gets assigned a dictionary. And the dictionary's keys are the column names to perform the function on. And the dictionary's values are the actual functions that we apply on these columns. So here we calculate the mean for the throwing speed and the median for the running speed. And as we can see, this creates this data frame. And yeah, now we have the mean value for the throwing speed and the median value for the running speed column. And this is again a lot of information that we get out of the data frame, because it's again, we get the mean throwing speeds per position, per throw arm, per team. So it's a lot of information that we get in a very, very clear way and a very comprehensible way. We can even extend that further by deploying multiple functions to one single column. And we achieve that by, let me just copy all of here. And we can assign, inside the dictionary of the aggfunc parameter, we can not only assign one function to a column, but assign a list that we, where we put in multiple functions that we want to apply on a column. For example, np.min, np.max, and again np.median. So we assign the running speed column inside our aggfunc parameter a list of functions, namely np.min, which is the minimum value, np.max, the maximum value, and np.median, so the median value. And if we execute that, we get this data frame here. And as we can see in the outputted data frame above there, we can see the name of each function at the top, which is quite nice because now this way we get the actual function names which we didn't have before, but this way it's again a lot of information that we see here. And that was the pivot table function. This function provides us with lots of opportunities to create a pivot table that puts out a lot of information about our data. And we learned how to use the function's various parameters to analyze our data in several ways. And we saw how to create a pivot table, how to do so with multiple indexes, how to apply key columns to group by, and how to add multiple functions for aggregation. And this was the tutorial. I hope you liked it. I hope you learned something, and I see you in the next one.